A DynamoDB Sparse Index is a special type of index where the index does not have an item for every item in the base table. The global and local secondary indexes are sparse by default. In this video, let's learn more about sparse index, how to create and populate data into them, and also how to query it from a .NET application. Hello everyone, welcome back to this YouTube channel. My name is Rahul and I make videos on .NET. This video is sponsored by AWS and is part of my .NET on AWS series. For every item in a table, DynamoDB writes a corresponding index entry only if the index sort key value is present in the item. Now in some cases, the items might not have those attributes and you might have an index on that attribute. In these cases, these items are discarded and not written into the index. So if the sort key doesn't appear in every table item, the index is said to be sparse. Now global indexes and the local indexes are sparse by default. So when you create an index, you specify a partition key and optionally a sort key. Now only items in the base table that contains those attributes appear in this index. Now looking at this table, you can quickly tell that this attribute 3, which has the value of champ, is only going to appear in certain indexes because this attribute is not populated on all the items. Now in this case, you can create an index on the attribute 3 and find all the championship matches and find who has won those championships. You can see that index down below where the GSI is on the partition key of award with the value champ, and you can find all the players that has got championships. Since a sparse index is either a global or a local secondary index, creating them is exactly as how you would create one of those. I have covered global and local secondary indexes in detail in my other videos, which will be linked here and also in the descriptions below. The difference with it being a sparse index is with the keys that you select for the indexes. So you need to choose a key that won't be appearing in all your items. So let's head off to AWS console and let's create a new index which will be a sparse index. So let's go into the tables. Let's go to weather forecast table. Now in this table, it has a partition key of city name and the sort key of date. This table stores weather forecast data for each city which is on a specific date. Now let's go into the indexes and create a new index. Now since this is an existing table, I cannot create a local secondary index. So I will add a new global secondary index. So let's say create index. In this case, let's choose the partition key as the date. Now for each given date, you need to find all the cities where there were extreme weather conditions. Maybe it was very cold, windy or hot, etc. Now let's specify this new property which is going to be is extreme weather conditions. Now, as the name suggests, this property is not going to be populated on all the records in this specific table because it's not going to be extreme weather conditions throughout the year in any city, hopefully. So let's select the data type as a number because that is going to be either 0 or 1, which is going to be true or false. So let's scroll down and let's specify the index with attribute projections as only keys. All I'm interested in this case is to list the city names and the dates, and if somebody wants the details of that, they can click into and drill down onto that object. So I don't want to be projecting any other attributes in this case. We learned about attribute projections in detail in my other index videos. So I highly recommend checking that out if you're new to that. So let's create the index, which is going to create the index on this existing table. So while the index is getting created, let's switch over to Rider where I have an existing solution that will be used to populate and query the data from this new index. So this is a default ASP.NET Core API application. It has the weather forecast item and the weather forecast controller. I started building this application from my DynamoDB querying video. This controller has different API methods which looks at different querying patterns and also data addition patterns in DynamoDB. So if you want to check out the different possibilities of interacting with DynamoDB, this repository is a good start. So now since we have added a new property, let's navigate into the weather forecast item and add the new property is extreme weather conditions. So let's make this as a Boolean property. So let's specify property of bool. And let's specify is extreme weather conditions. Now, since this property is not going to exist on all the items, let's make this as a nullable field. For a nullable field, DynamoDB skips this if this value is null. It writes the value only if it has a true or false. Now, in our case, we are only going to set this as true and not use the value of false. So let's build this and let's run this application. Now, this application is wired up to launch Swagger by default. So you see the Swagger UI once the application is up and running. So let's go down to the post method where we can add a new data to the weather forecast table. Now, this has the new property is extreme weather conditions. So let's navigate off to the DynamoDB. We can see that the index should be created by now. So let's refresh this. It's still in the creation process. So let's wait for some time for this to become active before we add the data. And right now this is active. So let's go back to the Swagger UI and start populating the data. So let's say try it out. So let's use today's date, which is 7/15. So let's give the city as Brisbane. So let's specify the temperature C as 1. And let's specify the extreme weather conditions as true. So for this state, on Brisbane, it is extreme weather conditions. So let's execute this data. Now this is going to post the data into this particular table. And since we have the property is weather conditions, it is going to be also added into our new index. Now let's add some more data for other cities. So let's say Sydney, and let's say it was 10 and it was not extreme in Sydney. So let's remove this attribute so that this will be null. So let's execute that. Now let's come back to our view table and let's refresh this index page. Now if I scroll on to the right, you can see the item counts in this specific index. Even though this doesn't get populated immediately as we add data, this will get updated eventually once in this UI. So let's go over to explore table items. Let's select scan and let's specify the index, which is going to be the DynamoDB extreme weather conditions index. So let's say run on that. Here you can see this has returned just one record, which is for Brisbane, because that was the only city where we specified is extreme weather conditions. Now if I switch over to the Swagger UI and let's add this for another city. So let's say London, and let's specify the temperature was 45 degrees there, which is also extreme weather conditions. So let's go to the new line after here and add the property extreme weather conditions and set that to be true. And let's execute this as well. Now this is going to add a new data onto that particular date and then also specify the extreme weather conditions for London. So if you were to come back to the items and run this again, you can see this has now the data of London. Now if you want to specify different dates, so let's specify 7 and let's specify on the 10th. For Mumbai, it was extreme as well. And let's specify execute. Now, if you add another date which doesn't have extreme weather conditions, so let's add Paris here and let's specify the temperature was 23 and it is not extreme on that date. So let's execute this. So now if I come back here and run this, you're going to see Mumbai, which had extreme, but none of the other records. I can also query this based on that index and specify a date key value. So if I was to choose one of these key values and specify that inside this and click run, it's only going to return the records that has that specific date. Now in this case, Mumbai had a different date. So if I come back, it was 7th of 10th. So let's specify 7 and 10 in here and run, and we just get back the Mumbai record. Now let's see how we can query this from a .NET application as well. So let's switch over to the Rider application. Let's stop this and let's navigate down where I have the GSI queries and the LSI queries inside this controller. So let's collapse this. Let's copy one of these queries, which is the GSI in this specific case, and let's paste it right after the LSI queries. So let's paste this in here and let's rename this to be a sparse index query. So let's rename this as sparse index query and let's say get using sparse index query. Now in this case, we are still going to get in as a date time, so that's all good for us. We are querying the weather forecast, so we've specified the table name for that. Now in this case, the index name is different, so let's switch over to AWS. Let's copy this index name from Explore Items Weather Forecast Indexes. Let's copy this index. Let's update this index name. Now the key condition expression is still on the hash date because we are querying by the date, and we are passing in the expression attribute names because the attribute name was using hash date. In this case, we had to use hash because date is a reserved keyword in DynamoDB. So all I'm doing here is specifying a parameter for the date and then specifying the actual value, which is date inside here. Now the expression attribute values is used to pass in the value for this parameter. So since we have specified it as :datetime, we specify :datetime and pass in the date as expected. I covered this in detail inside my 5 ways of querying DynamoDB, where we look at all these cases. You can also look at the videos on secondary index to understand more about these. So if I scroll down, we create the DynamoDB client and issue the query request that we just created using the client. Once we have returned back the items from the query, we map it to the weather forecast item and we return it back. Now in this case, this is going to be a sparse index item. So let's go and create a new item inside here. And let's call this as weather forecast sparse index item. Now based on your application, you would be naming this more appropriate. We could call this as extreme weather conditions item. Now I'm just going to give it as sparse index so that it's clear when you look at the code at a later point. So let's create this class. Now we just have few properties in this, like the city name, the date. So let's copy both of that and let's paste it in here. Now we could also add the property is extreme weather conditions because that's also going to get returned. Now in cases where you're going to have this as false, that would also be valuable. But usually you wouldn't set it to false because then it wouldn't be a sparse index. Unless you're going to have 3 values for that field, which is true, false, and then nullable. And in some cases, you might want true and false, but not have the null values coming into the index. So that's still a valid scenario. So let's leave this property in here and let's come back to the controller and let's update this to be using the sparse index item. So let's make sure to update this also in the return of this controller. So instead of GSI item, let's update that as well. So now we have the sparse index query all set up. So let's put a breakpoint here and let's click run. The Swagger UI is launched again. So let's scroll down and let's go to the get sparse index query, which we just added. Let's click try it out. Let's specify the date time. So let's use the date time that we copied before and let's click execute. Now this is going to hit the breakpoint. So this is first going to create the query request, which is going to set the table name, the index, and the key condition expressions, which passes in the datetime that's coming in as the API input. So once this is done, it returns back the response, which has the query response and the items inside this. Now, using the document mapper, this converts it into the C# class. So let's continue the execution and go back to our Swagger UI. Now, if you scroll down, you can see the 2 records for that specific date, which is Brisbane and London in this specific case. And it has the values is weather conditions true. Now, if you use the other date, which is for the 10th, and click execute, it's going to hit the breakpoint again. So let's remove this and press F5. And if you scroll down, you can see this has returned the data for Mumbai. Now, in these cases, all we are returning back is the city name and the date. Now you could use this in a list view which shows all the extreme weather conditions for that specific date, and someone could click into this record and get the further details from DynamoDB again. So as an example, so let's copy this date and let's come over to the first get method which queries the DynamoDB using a specific date. So let's say try it out. Let's specify the city name as Mumbai and specify the date that we are querying this for. Now in this case, we can return back the full item and show the full details of that specific date and the weather details for that specific date and city. So that's why we chose to project only the keys into the index so that we can save on the storage and also the amount of time that takes to write this item into that index. Now by having this index as sparse, I'm able to keep this query as minimal as possible. Now I don't need to query all the cities inside my database to find which dates and which cities had the extreme weather conditions. I'm able to directly use this index and get this data immediately for my users. This improves on the performance and also the time spent on the queries. I hope this helps you to understand what a DynamoDB Sparse Index is and how you can use this to your advantage when building your applications. We saw how to create and populate the data into this sparse index, and we also saw how to query this from a .NET application. We used nullable types so that we can represent the value and also ignore the value being written into DynamoDB in cases of it being null. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.